let's do an example where we find the curvature at a specific point. So given this planar curve, ti plus 1 over tj, let's see if we can't find the curvature. The first thing I notice is this is sort of a polynomial-like function. That's not a polynomial, but it's some sort of power of t. It's an integer power. So in general, standard differentiation is going to be fine. Let's not mess with getting the tangent vector. So let's use the formula that we were shown in the previous section, that the curvature is r prime cross r double prime of t, the magnitude of that cross product divided by the magnitude of r prime cubed. So given that, let's go ahead and pre-compute just go ahead and compute some of those components, and then we'll start putting them together. So r prime of t is I minus 1 over t squared j. And r double prime, that's going to be 0i, and that's going to be plus 2 over t cubed j. Since we have r prime here, let's go ahead and get its magnitude. So that's 1 squared plus negative 1 over t squared with a square root. So that's 1 plus 1 over t to the fourth. Now what I'm going to do is I'm going to actually factor out 1 over t to the fourth plus 1, so that I can pull that t to the fourth out. 1 over t squared square root of t to the fourth plus 1, or t to the fourth plus 1 over t squared. And the reason I'm going to do that is it's going to make our lives a little easier as we move along in this problem. So if I want to go ahead and cube that for funsies, then that's going to be t to the fourth plus 1 to the 3 halves, because that's to the 1 half, all over t to the sixth. So we now have that component. We have r prime and r double prime, but we don't have their cross product or that magnitude. So we need to go ahead and compute that as well. So I've really packed this in, but I really don't need to. But I guess that leaves me extra room here. So r prime r prime cross r double prime. So let's use this. Now we don't actually have a k component here, right? We don't. So in these particular cases, we're just going to use 0 for the k component. So 1, negative 1 over t squared, 0, 1, negative 1 over t squared, and then 0, 2 over t cubed, 0 for k, 0 for I, 2 over t cubed. So this is actually going to be fairly simple because there aren't that many things to put together. So in the I direction, I get 0i plus 0j plus 2 over t cubed k minus 0 k hat minus 0i hat plus 0j hat. So in this particular case, my cross product results in a vector that only has one component. Two over t cubed k. And that's kind of nice. So when I take its magnitude, I only get 2 over t cubed because I only have something in that direction. All right. And we might normally need to be careful about magnitudes here because, you know, you might want positive numbers, but since we're at t equals 1, we know that's going to come out to be positive, so we don't have to worry too much about that. So putting that all together, let's see, let me get my red marker out. I've got this piece up here. So that tells me that kappa is 2 over t cubed divided by t to the 4th plus 1 to the 3 halves, all divided by t to the 6th. So I've got a fraction over a fraction, so let's multiply by the reciprocal. So that's 2 over t cubed times t to the 6th over t to the 4th plus 1 to the 3 halves. So the t to the 6th is cancel. Now I do want to point out something here. We didn't have to do all this in terms of t. Notice that this was 4t equals 1. So by the time we got here, and by the time we got here, we actually could have subbed in for what t was. So in that particular case, that would just be 2 divided by 2 to the 3 halves. So 2 divided by 2 to the 3 halves. So we're going to get there. We're going to get the same answer. But I wanted to show you how to do this in general in case that you want to get curvature as a function of t. Because that's really what we're doing. We're getting kappa of t here. So that gets us 2t cubed over t to the 4th plus 1 to the 3 halves. So then kappa at the value where t equals 1 is 1 cubed over 1 to the 4th plus 1 to the 3 halves, which is 2 over 2 to the 3 halves, which is just what we said we were going to get, which is 2 over 2 square root of 2, getting us a final answer of 1 divided by the square root of 2. So curvature problems do take a while to compute. I would recommend that when you're first starting out, once you get to this point and this point, to simply just go ahead and sub in for the t value. Don't worry about doing this. This is a little bit extra step, but I did want to show you that we can think about kappa as a function of t.